Next up is the Robotics and Automation category, sponsored by Maxon. Maxon develops and builds high-precision electric drive systems that are among the best in the world, combining brushed and brushless DC motors, gearheads, sensors, spindle drives, and control electronics into complete mechatronic drive systems. For over 60 years, businesses from a wide range of industries, including medical technology, robotics, industrial automation, mobility, and aerospace, have placed their trust in reliable drive systems by Maxon. I would like to invite Tyler West to present his team's idea in the Robotics and Automation category, the Woodpeckr.
Okay, if I take this off here. All right, thank you everyone. Thank you for the opportunity. It's great to be here today. My name's Tyler, and today I'm going to introduce you to Woodpeckr. So Woodpeckr is a utility pole climbing robot that my capstone teammates and I built to assist in the job of a line worker in building and maintaining our electrical grid. We've worked on this idea for about a year now, from idea all the way to a fully functioning prototype. And today I'm going to walk you through what inspired us to do it, how it works, and where we see this going in the future. So let's start with the inspiration. This actually came from our University of Waterloo final and undergrad engineering project. And we're mechatronics engineers is what we're trained in. So we're looking to see how we can use robotics to change the world. We looked at the world around us, and we looked at all kinds of different problems and applications and tried to balance the amount of time that we had, our skill set, and where our interests lied. And what we decided on was the job of a line worker. These are the people who climb utility poles, they go up in bucket trucks, they maintain the grid, and they do all kinds of work in a very dangerous field. And we wanted to help them. So I actually talked to one of my friends who is a line worker, and we learned all about his job. They do lots of different things. They install hardware, they manage the vegetations on the poles, they inspect the poles, switch the power on, repair storm damage, and they drill those holes when they're installing new hardware. So we needed to find something that fit in about 8 months, was about how much time we had to build this. And we wanted to find a simple place to start. So what we decided was we were going to build a robot that can climb and drill utility poles at any height and any angle. And that's what we did. So here's how it works. At a high level, there's a hexagonal frame and 3 wheels that clasp onto the pole from each different angle, held on by a passive spring suspension system on each wheel. 1/3 of the device frame can be swung open with the hinges and latch that are on there in order to get it on the pole and off the pole when you're done using it. And then mounted on top of the frame is a 180-degree track to allow the drill to go to any angle and drill through holes. And then it's driven into the pole using a linear actuator and out of the pole with the same method. This is what the deployment and setup looks like when we were testing. First, you remove it from the trailer, then you open the hinge and swing the latch open, put it around the pole, adjust the wheels, and then refasten the latch before we move to the next step. The next step is a system we had to design to deal with the compression of the springs. So we actually designed the system so that a bolt holds the compression of the springs, and you pre-compress them before putting it around the pole. That way, when you actually put the latch in place and have the device in its correct position, you can then loosen that bolt, and the compression moves from the bolt onto the pole, which generates enough friction force to allow you to be able to climb up the pole. The climbing up the pole looks something like this. There's an electric motor on each of the individual wheels on the device. And then there's a control system that makes sure that the device stays balanced as it's going up to ensure that it doesn't fall by becoming off balance and then slipping down the pole. On top, there's a tool mounting track. It's 180 degrees, like I said, and it uses a stepper motor to drive it around. And you can just kind of see how it works there. And then here's a video of how the drill works when we were testing it. Essentially, it's just a linear actuator driving it in and out. And then there's another stepper motor that controls the trigger on the drill for how fast the bit is moving. Some of the key innovations associated with the design include, one, it's adjustable to different pole sizes. So for those of you who don't know, wooden poles come in many shapes and sizes and classifications for different purposes. So we needed to design around that. So what we ended up doing was we actually had a system where we used a little latch there, I guess, with individual holes for the different diameters of poles that you're operating on. And how it works is you kind of grab it with two hands and you can pull the wheel to the correct diameter of the pole that you're operating on. And then you do that before you loosen that bolt and apply the compression onto the pole. The other one was the 180-degree track so that we can drill the holes at any angle. We're on a bit of a budget, so what we did was we CNC'd out a piece of plywood into this shape that we needed here. And we actually 3D printed each individual piece around this entire thing. And what they are is it's inspired from like a planetary gear, so that the stepper motor drives the gear on the inside, and then there's a gear on the outer track so it can glide around. And that's about the resolution that you could have to find any angle around the pole. And the final innovation is that it's a completely self-contained electrical system powered by an e-bike battery that we managed to find. And this way you don't need to have an additional power source like a generator on the ground or a tether running from it. Some future applications we see include using it as it was originally designed to drill holes accurately during new pole installations to mount hardware on after the fact. The next one is we could swap out the drill attachment for a different attachment such as a concrete saw to help with the job of removing concrete poles in urban areas. Here, this is a really dirty job right now where a lineman has to get up in a bucket truck and they get sparks and dust and different things in their face while they're doing it. So our tool would swap them out. It would go up, cut off a chunk, a crane removes it, come down, cut off another chunk, a crane removes it until the entire pole is removed. And then the final one we want to use it for is replacing it with a wrapping attachment. So as you may know, there's a pretty big wildfire problem coming up and only increasing with climate change. So one solution that a lot of utility companies are using now is wrapping these poles in a fireproof intumescent mesh wrap. Right now, people have to climb up the poles or go up in a bucket truck in order to do this. So we would swap out our attachment for a wrapping attachment instead. It will go up and wrap instead of a person. And finally, our market impact. We really believe that using this technology, lineman crews can become more efficient and have faster operations. There's also improved lineman safety in terms of keeping them on the ground more often at less risk of heights and less risk of being electrocuted while up there. And overall, we really hope that this is a next generation platform on which utility robotics can be built to continue to make the job of a lineman safer. Thank you.
Other questions? Anyone? The back, please.
Yes. It's great that you did all of this innovation and you've solved a lot of problems from a technical side. Have you gotten any customer feedback at all? And have you said you have spoken with one lineman. What are they willing to pay for it? And what's your cost to produce it?
Yeah.
And are they willing to use it?
So it's very early in terms of, this is a V1 of the prototype. We worked with our local utility, Nova Power, when we were testing. That's where all that testing footage comes from. I don't have an answer on the willingness to pay aspect of it right now. That thing's about 200 pounds right now, so we would need to do a full V2 spin to actually put it in front of people to test if they would be willing to use it if it was a lighter form factor that like only one or two people could be able to carry it onto the pole. And that would be the next stage of development that we would need to do to help answer that question.
Great idea. Anything with not touched by humans at some distance, great. But one thing I've been noticing since, again, part of my job, vibration.
Yes.
Because vibration in this case may change the alignment, even can lead to a failure, stuff like. So how you control the vibration levels and that stuff?
I think, again, it comes down to a V2 version of this. So right now we have that passive spring suspension system on there to control the vibration as best as we can. We really just wanted to see if we could build this thing in the first one. We have thought about more advanced systems that would use like an active suspension system with compensators on there, or potentially something that leverages gravity a little bit better in its form factor to allow some stability on the pole.
Or in fact, what you can do, you can have a vibration sensor.
Yes.
And include the signal from the vibration sensor
yeah.
to adjust the controls.
True.
Yeah.
Thank you.
Yeah.
Any other questions? One at the back.
Have you considered other applications for this?
Yeah, there's definitely applications in things like we've looked at like oil rigs. There's other pulls out there. Not too much, but we've looked at them and haven't really committed to them yet, though. Yeah.
So 5 seconds. So one of the applications, I don't know if there's anything with wind turbines but I'm not sure if that's applicable. Probably not.
I have thought about that one. If we just take our device and make it like, I don't know, 10 times larger or something like that, much bigger pull, but you could use a similar system. I think there's some out there for wind turbines actually that have a similar form factor to ours. Yeah.
Great, thank you.
Thank you.
At this point, we'll take a short 15-minute break and then resume with the remaining 4 categories. Thanks everyone who's presented so far.
Shake it up. Jump, dance all night. Dance all